hopefully by now everyone has their homework out. If not, get it out quickly. Let's take a moment to check these. If you look at number 1, it talks about a controlled study. So we're going to go with causation for this one. Number 2, there's no indication of a study, correlation. Number 3, controlled study, causation. Number 4, no indication of a study, so correlation. Number 5, also no indicator of a study, so correlation. Number 6, we'll discuss this one tomorrow, but this one talks about a controlled study. So for this particular case, you can say causation, but I want to talk to you guys about number 6 tomorrow. Number 7, correlation. Number 8, correlation. And number 9, once again, because of the controlled study, we'll go with causation, but I'd like to have discussion about this tomorrow. So while we're having discussion, numbers 10 through 13, I would like you to get in groups of 2 to 4. You can just turn around. You don't really have to move your desk. And talk about your answers for these, because the answers can vary. I want you to discuss in groups. And any questions you might have about this, I'd like you to ask me tomorrow. So if you could take a moment to pause the video and use 3 or 4 minutes to discuss these in groups, that'd be great. Go ahead and hit pause now. Okay, welcome back. This was on your second worksheet, so take a look at this. This is where we were to graph the scatter plot and the correlation. So this one, when we plotted, it looks quite linear and it has a positive slope. So we would say this is a strong positive correlation. And then number 2, when we graph it, our points were all over the place. And when it looks like this, we can't really find a correlation at all, so there's approximately no correlation on this one. Okay, that is not your bell. That is the bell that's going off while I'm recording. But I would like you to go ahead and pull out your notes for the day, and we're going to take a look at these notes and go through them. So if you haven't passed out the notes, go ahead and hit pause here and pass out the notes. But if you had, students, go ahead and pull those out, and I'm going to go ahead and move to the notes page. All right, today we're going to look at how we can model data using linear regression. And today we're going to use line of best fit. And we're going to approximate that line by graphing today or by using points that we can see on a chart. Number 1, part 1 is a review. Remember, to graph a linear function, we leave it in the form y equals mx plus b. So first we're going to find the slope, m. Well, our slope is y2 minus y1 over x2 minus x1. And then we'll find the y-intercept. So graphically, we can find the inner slope by simply looking at where it crosses the y-axis. Or, if we're given 2 points, we can find the equation for the line and then note the y-intercept. So let's take a look at example 1. We're given 2 points where I find the equation for a line. So this is complete review, but what you would do is find the slope, y2 minus y1 over x2 minus x1. The slope of this line is 1/2. Then we're going to plug it into point slope. Hopefully you remember point slope. Point slope is y minus y1 equals m times x minus x1. So y minus y1 equals m times x minus x1. All right, so in this case, I'm going to just pick a point. I can pick the first one, and I get y minus my y1 equals my slope times x minus my x1. So it's y minus 2 equals 1/2 times x minus 3. We're going to distribute that 1/2 to put this in slope-intercept form. Now in class, we didn't do that. We just left it in point slope, which we can. It's just a little harder to use when we're making predictions, which is what we're going to do today. When you add the 2 to both sides, you get 1/2 x plus 1/2. And there's the equation for the first one. Y equals 1/2 x plus 1/2. Go ahead and hit pause, and I would like you to try example 2. Please hit pause on the video now, and everyone try example 2. Welcome back. So first thing we did was we found the slope, and we got the slope with -5/2. So then we plug it in. Y minus y equals our slope, -5/2, times x minus the x value. And so for this one, we get y equals negative 5/2 x plus 16. Okay. Now, we do have some new vocabulary for today. First, we're going to talk about linear regression, line of best fit. It's a line that expresses a linear relationship between an independent variable, which we're going to call x, and a dependent variable y. Now, for a data set, the line of best fit is the line in which the sum of the squares of the differences between the observed and the predicted values is smallest. Now, this part right here, this is what we're going to use our technology to find tomorrow. Today, what we're going to do is basically look for a line that goes through the most points, but not all the points, or a line that is shows a good trend of the data. And that's what we're going to use for today. Tomorrow, we're going to use the calculator to actually find this part, all those least squares. Now, today we're just looking for an equation that models the data. We're going to use that as our prediction equation. Our prediction equation is an equation that models the data. It's a line that's drawn through to show the approximate relationship formed by the points. And we're going to do this by hand today. There's two things we can do with this. Interpolation is where we make a prediction within the values we already know. That's what we're going to do down here in number 1. And then extrapolation is where we make a prediction beyond the values we know. And I'm going to add a U-try to this one so we can do that also. So what do? We're given a situation. The table below shows the number of juniors enrolled in advanced algebra to high school in 6 of the last 7 years. We lost the data for the 3rd year. So what they're asking us to do is estimate the number of students enrolled in advanced algebra that 3rd year. And it asks us to use a line of best fit. So what we're going to do is what we learned yesterday about graphing our scatter plot. So we're going to label our axis, we're going to plot our points, and then today what we're going to do is draw in a line that represents the data. So what I did was I drew in one where some of the data was above the line, some of the data was below the line, and I try to get it through some of the data points. Well, now that I have this line in there, and let's go ahead and hit pause, and I'd like you all to graph this data and try to draw in a line that looks similar to mine, just for the example. After this, ours may be a little different, and that's totally fine. So go ahead and hit pause now. Please hit pause. Okay, welcome back. Now that we all have the same graph, we're going to write the equation for this line. Well, I'm given the graph, so I can write the equation by doing the slope. And be careful, on my graph, I counted on this axis by 1 and on this axis by 5. So when I count my slope, it's up 5, 10, 15, 20, 25, but only over 6. So my slope is 25/6 between the 2 points I picked. And I picked these 2 points by looking where are 2 points that on this graph goes through something easy to read. Looks like one here, looks like one here. Looking for where it goes through the crosshairs. And then we see our y-intercept is at 25. So there's an equation for this data. Now, if we want to know year 3, now that we have the equation for the data, all we have to do is plug in a 3. And this gives us 37.5 students. Well, we're not going to have 0.5 of a student, so we'll say approximately 38 students for year 3. Okay, so on that one we did some interpolation where we looked inside the data we were doing. Now let's do some extrapolation. What if I asked you to predict year 10? What would be the number of students enrolled in this class in year 10? Well, same thing. Plug in 10 for x. And we're going to get approximately, we're going to have to round here, approximately, give you a moment, 67 students. And if we look at our data, that's how it's trending, so 67 does make sense. Okay, now let's go to that second note page. This one we're going to do number 1 together, and I'm going to have you start with number 2 for your homework. So your homework is to finish up number 2 on this page and then complete the packet we started in class yesterday. All right, in this it gives us a table of temperatures, and then it asks us to graph the function. So go ahead and hit pause again, and I would like you to graph those temperatures. Okay, welcome back. So hopefully your graph looks somewhat like mine. And when I drew in a line of best fit this time, it actually went through 2 of the points I was given. So now I have some above, some below, and it went through. So this one went through this point here, and it also appears to have gone through 4 and the 5. So let's pick one. Let's say it went through this one. Okay. So I've graphed it, and now I'm supposed to describe how the temperature changes. Well, on this one, we had an increase followed by a decrease. And when we look at this tomorrow, we're going to try this example tomorrow using our technology, and we're going to look at that correlation coefficient and see if a linear model is a good model for this data. But today, let's go ahead and make that linear model. So since this line went through 2 of the points we're given, we don't have to estimate as much. We can use these 2 points to find the equation for the line. So we're going to find the slope of that line, 39 minus 34, over 5 minus 1. So 5 minus 1. So the slope of this line is 5/4. So it's y minus, and I can pick one. I'll say y minus 34. Equals the slope, which I just found was 5/4, times x minus the 1. And I'm going to distribute here and add like terms. And you can use your calculator. So I'm getting 5/4 x. This is a negative 1.25. And when I add 34 to that, I get a positive 32.75. So this is an equation that models this data for this given situation. And we can use this, our prediction equation, to predict what would happen on the 6th day. So we would say y equals 5/4 times 6 plus the 32.75. And that would give us an approximate temperature of 40.25 degrees. Okay. After you finish taking your notes, I would like you to do number 2. And then work through the entire packet. Tomorrow, I may collect these for accuracy, so I want you to be as careful as you can be. I may not grade them all for accuracy, but I may have you turn in 1. So, be ready for that, and we'll see you tomorrow.